Young petroleum was born in an oil well that was drilled about 6 miles deep beneath the Earth's surface. Its development took millions of years to be transformed by intense heat and pressure. This process produced one of the most versatile substances that exists in our daily lives. Petroleum can be found in many products like plastic, rubber, crude oil, and even detergent, fertilizer, synthetic fibers, vitamins, plastic, CDs, DVDs, candles, and Band-Aids. Petroleum's ability to appear in all of these products can be attributed to its structure-property relationships. Structure can be described as the molecular formula, size, and shape of a molecule. These give rise to electrostatic properties like polarity or hydrogen bonding that allow molecules to interact with one another. These structures define the properties of the molecule, which can be described as physical or chemical. The physical properties like melting point, boiling point, or solubility determine how the substance can be used and which environments they will perform best in. The chemical properties like reaction rate or equilibria determine ionic, acidic, or basic strength.
Throughout its growth, petroleum went through different stages of development. For its first round through the refinery, petroleum was designed to become plastic. The structure of petroleum became repeating organic polymers composed of carbon, oxygen, sulfur, and nitrogen. These different molecular groups bond to the backbone, which allow it to have properties like hardness, heat resistance, and high density. The intramolecular forces present in plastic occur between the polymer chains, which prevent movement. However, plastic is stronger when it is cold because as the molecule is heated, the intramolecular forces are weakened, which allow the polymer molecules to slide over one another, allowing the structure to become flexible but not resilient. These properties allow it to have certain functions like protection and preservation. Plastic is a good example of the structure and property relationships that occur because it presents itself in many forms like bags, bottles, and containers. The more movable items would have weaker intermolecular forces that allow flexibility, while the stiffer items would have strong intermolecular forces which cause rigidity.
Although rubber was originally formed from tree sap, it is now produced as a petroleum product. As a rubber molecule, petroleum has now dropped its sulfurs and nitrogens that it gained as plastic, transforming into repeating units of isoprene polymers, forming a cis polyisoprene, which is the main constituent of rubber. As rubber, petroleum can do many things that it couldn't as plastic. For example, rubber is able to stretch, it is highly resilient, and even waterproof. Rubber is capable of being flexible, stretchy, and waterproof because of its structure. Since the petroleum in rubber consists of hydrophobic compounds, it will not react with water, and those bonds will form London dispersion forces that allow weak intermolecular interactions, but the intermolecular interactions will be stable so that the product can still be versatile and moderately strong, but not indestructible. Sadly, not everything lasts forever, and the rubber soon finds its way to a recycling plant where it will be refined to make a new product.
A range of many hydrocarbons is alkanes, cycloalkanes, aromatic carbons, and spaltenes. As crude oil, petroleum can differ its structure further to become butane, gasoline, jet fuel, kerosene, fuel oil, or diesel fuel. Petroleum is now capable of being burned to be used as an energy source. This new structure gave rise to new properties like being able to combust in order to run an engine or provide heat. Sadly, this process converts the petroleum into heat, which is emitted and is no longer renewable. Gasoline is a compound that is known for its flammability, which results in harvestable energy that we can use for our daily functions like powering our cars or heating. The structure of gasoline is highly reactive with oxygen, so when a spark is present, the thermal energy provides enough energy to overcome the repulsions of the electron clouds between the two molecules, allowing the combustion to take place.
As the day of this petroleum molecule ends, it will take millions of years to form a new one. So take note of the products that you're using as it went through a long journey of alteration and modification to its structure in order to produce the properties that you use that product for.